Edwin Hubble, the man who discovered the expanding universe. Imagine standing beneath a completely dark sky. No city lights. No buildings. No traffic. Just thousands of stars scattered across the darkness. For most of human history, people looked at that sky and believed they understood it. They imagined the stars were fixed points of light, suspended inside a vast but unchanging universe. The universe, they believed, had always been there. And it would always remain the same. Then one man looked through a telescope and realized something so enormous that it changed humanity's place in the cosmos forever. The universe was not standing still. It was expanding. That man was Edwin Hubble. And his journey to that discovery was anything but simple. Long before his name became famous, Edwin Powell Hubble was an ambitious young boy growing up in Missouri in the late 19th century. He was born in 1889, at a time when astronomy was still filled with enormous unanswered questions. As a child, Hubble was fascinated by stories of adventure, exploration, and distant worlds. He was an excellent student and a talented athlete, particularly in basketball and boxing. His teachers noticed something unusual about him. He wasn't satisfied with simply knowing an answer. He wanted to understand how the answer had been discovered. That curiosity would eventually carry him far beyond the small towns of his childhood. Hubble attended the University of Chicago, where he studied mathematics and astronomy. But his life seemed to be heading in a completely different direction. He became an accomplished athlete. He even earned a prestigious Rhodes Scholarship and traveled to England to study at Oxford University. There, he studied law and literature. For a while, astronomy seemed like something from another life. But the stars were waiting. After returning to America, Hubble completed his studies and eventually earned his doctorate in astronomy. Then came the First World War. Hubble served in the United States Army, reaching the rank of major. When the war ended, he returned to science with renewed determination. And this time, he had his eyes fixed on one of the greatest astronomical mysteries of all. What exactly was the universe? At the beginning of the 20th century, astronomers had a major problem. They knew about the Milky Way. They knew it contained enormous numbers of stars. But they didn't know whether the Milky Way represented the entire universe. Beyond it, there were mysterious cloudy objects called nebulae. Some astronomers believed these nebulae were relatively small clouds inside our own galaxy. Others suspected something far more extraordinary. Perhaps some of them were entire galaxies, vast collections of billions of stars existing far beyond the Milky Way. The debate became known as the Great Debate. And the answer would require a telescope powerful enough to see farther than anyone had ever seen. That telescope was the Hooker telescope at Mount Wilson Observatory in California. At the time, its 100-inch mirror made it one of the most powerful telescopes on Earth. And in 1919, Edwin Hubble arrived at Mount Wilson. He had found his battlefield. Night after night, Hubble climbed the mountain and entered the observatory. The world below disappeared into darkness. Above him stretched the enormous sky. He photographed distant objects, studied their light, and carefully analyzed stars. One particular type of star became extremely important. They were called Cepheid variable stars. These stars have a remarkable property. Their brightness changes in a predictable pattern. By studying that pattern, astronomers could determine their true brightness. And once they knew the star's true brightness, they could compare it with how bright it appeared from Earth. That allowed them to calculate its distance. It was like recognizing a flashlight whose true power you already knew and estimating how far away it was by measuring how faint it appeared. Hubble began searching for Cepheid variables inside distant nebulae. Then, one night, he found something extraordinary. Inside what was then called the Andromeda Nebula, Hubble identified a Cepheid variable. He calculated its distance. The number was astonishing. Andromeda was far too distant to be part of the Milky Way. It was another galaxy. A gigantic island of stars far beyond our own. Suddenly, the universe became unimaginably larger. The Milky Way was not everything. It was only one galaxy among countless others. Hubble's discovery transformed astronomy almost overnight. But he wasn't finished. In fact, his most astonishing discovery was still ahead. Hubble began studying the light coming from distant galaxies. When light from these galaxies was analyzed, something strange appeared. The spectral lines were shifted toward the red end of the spectrum. This was called redshift. The farther away the galaxy appeared to be, the greater its redshift tended to be. Hubble compared the distances of galaxies with their velocities. And then he saw the pattern. The farther away a galaxy was, the faster it appeared to be moving away from us. The relationship was astonishingly simple. Distance increased. Recession speed increased. The universe was expanding. Think about what that meant. The universe was not a static stage containing stars and galaxies. Space itself was changing. The cosmos was growing. Imagine dots drawn on the surface of a balloon. As the balloon expands, every dot moves away from every other dot. The dots themselves aren't necessarily traveling across the surface. Instead, the surface between them is stretching. That is roughly how astronomers visualize the expansion of the universe. Hubble's observations provided powerful evidence that the cosmos was dynamic. But there was a remarkable twist. The mathematical possibility of an expanding universe had already been suggested by another scientist. His name was Georges Lemaitre. And even before Hubble's observations, Albert Einstein's equations of general relativity had allowed for a changing universe. Einstein initially preferred a static cosmos. He even introduced a mathematical term called the cosmological constant to keep the universe from collapsing. But when the evidence for cosmic expansion became difficult to ignore, Einstein reconsidered. The universe was moving, changing, evolving. The old picture of an eternal, unchanging cosmos was disappearing. Hubble had helped open the door to modern cosmology. Yet the man behind the discovery remained surprisingly complicated. He was ambitious. He wanted recognition. He cared deeply about his reputation. He sometimes argued fiercely with other astronomers. And he was determined to secure his place in scientific history. But beneath that ambition was genuine fascination. Hubble wanted to know what was out there. He wanted humanity to look beyond the boundaries of its own galaxy. And now the universe had revealed something extraordinary. We were not at the center. We were inhabitants of one galaxy among billions. Earth was a tiny world. The Sun was an ordinary star. The Milky Way was one galaxy among an enormous cosmic population. And the observable universe was vastly larger than previous generations had imagined. Hubble's discoveries changed not only astronomy but also human imagination. Suddenly, science fiction seemed less like fantasy. Other galaxies existed. Other stars existed. The possibility of planets around other stars became easier to imagine. And the question naturally followed. If the universe contains billions of galaxies, and each galaxy contains billions of stars, could there be other worlds like Earth? Hubble himself did not have the technology to answer that question. But he helped create the scientific framework that would eventually allow future generations to investigate it. His work also transformed the way scientists classified galaxies. He developed what became known as the Hubble sequence, organizing galaxies according to their shapes. Some were spiral galaxies. Some were elliptical. Some were irregular. The night sky became a cosmic library, with billions of galaxies arranged in different forms. But Hubble wanted even more. He dreamed of a telescope beyond Earth's atmosphere. Earth's atmosphere blurs starlight. A telescope in space could observe the universe with extraordinary clarity. During his lifetime, that dream remained unrealized. But decades after his death, humanity finally built such an instrument. In 1990, NASA launched the Hubble Space Telescope. It was named in his honor. And the images it eventually captured became some of the most breathtaking pictures in human history. Nebulae glowing with brilliant colors. Galaxies colliding across unimaginable distances. Stars being born inside clouds of gas and dust. Ancient galaxies whose light had traveled for billions of years before reaching Earth's telescopes. The telescope allowed humanity to look deeper into space and therefore further back in time. Every distant galaxy became a kind of cosmic time machine. Its light carried information from the ancient past. When we look at a galaxy billions of light years away, we don't see it exactly as it exists today. We see it as it was billions of years ago. The deeper we look into space, the deeper we look into cosmic history. That idea would have amazed Hubble. But his own life was approaching its final chapter. Hubble continued working at Mount Wilson and remained deeply involved in astronomy. He hoped to make even more discoveries. He wanted better telescopes, better measurements, better understanding. But his health eventually began to decline. In September 1953, Edwin Hubble died suddenly of a cerebral thrombosis. He was 63 years old. He left behind no autobiography explaining his life. He left behind no great final speech. Instead, he left something far more powerful. Evidence. Observations. Photographs. Measurements. And a new vision of the universe. Before Hubble, humanity could imagine a universe filled with stars. After Hubble, we knew something much bigger. We lived inside one galaxy. Beyond it were other galaxies. And those galaxies were moving apart as space itself expanded. Today, scientists have pushed the story much further. We know that the universe is approximately 13.8 billion years old. We know it began in an extremely hot, dense state and has expanded over cosmic time. We know that the expansion is accelerating. We now study dark matter and dark energy. We search for planets orbiting distant stars. We detect gravitational waves produced by violent cosmic events. We send robotic spacecraft across the solar system. And powerful space telescopes continue looking deeper into the universe. Every discovery brings new questions. And perhaps that is the greatest lesson of Edwin Hubble's life. He did not discover everything. He didn't solve the universe. He simply opened a door. And behind that door was a cosmos far larger and stranger than anyone had imagined. Think back to that lonely mountain in California. Imagine Hubble standing beside the enormous Hooker telescope late at night. The observatory is quiet. The air is cold. The stars shine above him. Inside the telescope, distant galaxies appear as tiny points of light. Each one is separated from us by unimaginable distances. Each contains billions of stars. And Hubble realizes that the universe is not frozen in place. It is moving. Expanding. Changing. The darkness between galaxies is stretching. The cosmos itself is alive with motion. Perhaps at that moment, Hubble understood something that no equation could fully express. Humanity had spent thousands of years looking at the sky and asking where we belonged. Now, for the first time, we had evidence. We were small. Almost unbelievably small. But we were also capable of asking questions about the entire universe. A species living on a tiny planet had built machines capable of seeing billions of light years into space. We had looked outward and discovered our cosmic insignificance. But we had also discovered something else. Our capacity for curiosity. Edwin Hubble's greatest legacy is therefore not simply the discovery of an expanding universe. It is the reminder that the boundaries of knowledge are never permanent. What seems impossible today may become tomorrow's scientific breakthrough. What appears to be the entire universe may turn out to be only one small part of something much larger. And somewhere, perhaps on another world around another distant star, another curious mind may one day look into its own night sky and ask the same question humanity has asked for centuries. How big is the universe? The search continues. Because the universe is still expanding. The galaxies are still moving. The light is still traveling across the darkness. And humanity is still looking up. Edwin Hubble simply helped us see how enormous that darkness really was.